Hi friends, welcome back. Today we're going to be talking about volume of 3D objects. In particular, we're going to be talking about cylinders. You can think of these as circular prisms because they have a base that is a circle, and then they are connected by, if we unfolded it, a very long rectangle that looks like this. So we're going to be talking about finding the volume of these cylinders. Think of it like a can of soup, right? If you pulled the label off, you would have a long rectangle. Okay, so the volume for any prism is going to be, let's write prisms here, finding the area of the base times the height. Now you'll notice I'm using a capital B here. That means that we're talking about the area of the base. Area of the base. If you see a little b, sometimes you'll see it when we say, like, for example, when we're talking about finding the area of a triangle, we'll say, oh, you need to measure the height, multiply the height times the base and divide by 2, and you'll see there's a little b. This is a 2D object, and so when we're talking about the base of a 2D object, we're talking about it with a little b. So just make sure that you note that difference. Okay, so as I mentioned, prisms are the area of the base times the height, but you know, a circular prism, aka a cylinder, is going to be a bit different. That specific formula is going to be the volume equals, now the area of the base. Remember, finding the area of a circle, and here's how I remember that. Let me give you a quick tip. The circumference, which is all the way around the outside of a circle, that we normally call that the perimeter on everything else, but on a circle we call it circumference. Circumference, I remember by doing this. Cherry is delicious pie. And in this case, the D stands for the diameter. Friendly reminder, diameter goes all the way across your circle. It's a radius plus another radius, because remember, a radius is just half of the diameter. I've been doing this 15 years and I still can't draw a perfect circle. There we go. There's our radius. So circumference. Cherry is delicious pie. Apple pies are 2. Apple pies are 2. And you notice I kind of wrote that out of order. I like to keep my pie at the end, just like, you know, when you're eating dinner and you want to eat your dessert last. We put the pie at the end there. And this is so we can keep things in terms of pie. And so we'll talk a little bit more about that. Okay, so now let's jump back to volume. For a cylinder, we know we've got to find the area of the base, which is the radius squared times pi, and then we're going to multiply it by its height. We are multiplying each of those things, and remember, the commutative property tells us that we can multiply in any order. 1 times 17 is going to be the same as 17 times 1. So as I mentioned before, I like the pi at the end, so I'm going to reorder this guy. We're going to take the radius squared, we're going to multiply that by the height, and then we're going to multiply that by pi. And there's a reason, a method for my madness on this. But go ahead and write down that formula for finding the volume of your cylinder. Cylinder. Yep. Cylinder. Well, let's see if I can spell correctly today. All right, so that's your volume for your cylinder. Go ahead and write that down. Now we're going to practice finding the volume for some of those. So, for example, let's say, and I'm going to zoom in a little bit so you can see this a little better, of course. So we've got a couple of cylinders here. There we go. Okay, so we've got a couple of cylinders here that we need to find for which we need to find the volume, right? And so again, we're going to write that down so that you have it. To find the volume, we do the area of the base, which is radius squared times pi, and then we multiply it by the height. So radius squared times the height times pi. So for this example here, we're going to say, all right, well, they're trying to trick you because you see they give you the full diameter, which is all the way across. Our diameter is 20, but our radius is 10. So when we go to find the volume of this guy, we're going to say, okay, the volume is 10 squared times the height, which is also 10, times pi. So in that case, when we have 10 squared, which is 100, times another 10, we get the volume equals 1,000 pi. And we've got to remember our units when we're doing geometry. So we're looking at centimeters here. So that's centimeters cubed. And that's because our area is squared times our height, which is just to the first. Now, this is leaving it in terms of pi. Sometimes this is a far more accurate answer, but often we use 3.14 to represent pi. And so if we've got 3.14 and we multiply that by 1,000, we end up with volume equals 3,140 centimeters cubed. So you can either leave it in terms of pi or you can go ahead and multiply it out by 3.14. Okay, so that is a good example because that one's just straight on its side, or straight up and down. So, but you can see also that the diameter, you need to cut that in half. Let's talk about these ones that are on their side. So even though this is on its side, we still have to remember that our height is connecting our two non-rectangles. So in this case, our height, despite it being on the bottom here, is going to be 6 inches. So we have a diameter of 15. Oops, let's see if I can write numbers correctly today. Of 15 inches. We have a height of 6 inches. And because our diameter is 15 inches, remember our radius is just half of that. So, it's actually 16 inches. I'm sorry, guys. So our radius is going to be half of that, which is just 8 inches. 8 inches. Okay, so let's go ahead and find the volume of this guy. If we do that, we end up with, again, you're going to take the radius squared multiplied by the height multiplied by pi. So our volume is our radius, which is 8, because that's half the diameter. So 8 squared times our height, which again is the thing connecting the two circles. That's going to be 6 times pi. So we get 64 times 6 pi. And when we do 64 times 6, we get 384 pi. And because we're talking volume, remember we've got to use cubed. So inches cubed. And a way of thinking about that. So this is in terms of pi. Now we're going to redo the problem and we're going to do it where we multiply pi by 3.14. But I want to show you why those units work. What we're doing is finding the volume, which equals, again, the area of the base. The area of the base is radius squared times pi, not that height part. So when we go to find the area of the base, we get 8 times pi, and that's going to be inches squared, because when we find the area, we get inches squared. Then we're multiplying it by the height, which is 6 inches. So what you see here is if I take this 6 and this 8, 8 squared. Let's see if I can get this right. Sorry about that, guys. When I take those two things and I multiply them together, I get 384. But you see we have inches squared times inches is going to give us inches cubed. And then we got our pi over there, so times pi. So if we take, but that's where the inches cubed come from. Hopefully that makes a little bit more sense. You just need to remember when you're finding a 3D object and you're finding the volume of it, you need to do inches cubed or units cubed. But now if we take 384 and we multiply that times 3.14, we end up with 1,205.76 inches cubed. So again, this guy's in terms of pi, which is a more accurate answer, but sometimes we use 3.14 to represent pi. And when we do that, we get this answer right here. Hopefully you found this helpful. Look forward to seeing you next time.